Hello, Professor Lee. I'm Santosh Thapa. I'm a distance learning student this semester for the big data, and this is the proposal phase of the project. And my topic is data analytics on airlines traffic. So, on the introduction slide, with there has been like a, I mean, the air traffic is airlines zone is there are a lot of like 75,000 air flights being taken place in a minute, which can be seen from the flightradar.com website. And with these a lot of huge mega data, we can apply the data analytics and we can predict the on-time airlines performance. So this project is basically about that. And there are three main data sets, which are the consecutive years individual data of flights on the year 2013, 14, and 15 taken place in USA, which was extracted from Bureau of Transportation Statistics. The main data analytic technologies which will be used in this project is MapReduce, Spark, and Hive. The output will simply summarize the available data by time periods, airport, and carrier, based upon the temporal effects such as time periods which are more prone to delays than others will be determined, and similarly on the spatial effects like airports more prone to delays, and similarly carrier effects like if some carrier or airlines are more prone to delays. So the main problem statement of this project is like there's always flight delays or some cancellations being taken in the flights, which are very troublesome, and depending upon the time period of the delay, which can maybe on the day, month, or certain season, like winter or summer or spring or fall, the on-time performance of the flights becomes unattainable. It's uncertain, and similarly the scheduled flights get delayed more, and in some cases gets cancelled also. These all are very troublesome to the passengers. So in order to uh, avoid these problems, the goals that I have set for this project are to find out the best delay of the day or week or year with minimum delays, to find out the flight departures having delays more than 15 minutes, to check out if the older planes are more prone to delays, and to know if the weather has any effect on the flight delays, and similarly to know the cascading relationship on the failure delays, like if one airport is if a flight is departing from one airport, does the delay affect the uh, affect does the delay affect to the corresponding flight as well? So that can be also find out. So the data analytic techniques that I will be using are the three technologies, which are MapReduce, Spark, and Hive. There will be main 5 findings which will be made on this project, under which one will be executed using MapReduce, one by Spark, and the other three remaining by Hive. So the MapReduce technology is basically developed by Apache Hadoop project, which mainly breaks the big and huge data into manageable chunks. It has two phases, map and reduce, and in between the map and reduce there's a shuffle and sort phase as well to get more defined output. And here I have used the map reducing technology to get the flight's departures which were delayed or by greater than 15 minutes, and considering the days, months, and seasons. So the mapper function here simply parses the data line by line. It will extract the fields of unique carrier flights and arrival, I mean the departure delay. So the key is the flight's unique carrier, and the value will be the numeric departure delay, which will be in the int writable type. And in the mapper it uses just calculates if it determines the departure time by that the time period departure time, the if it's greater than 15 minutes, by just subtracting the actual departure time with the scheduled departure time. And if it's greater than 15, the delayed status will be updated with a set of 1, and which will output the new text with the variable new text and new in writable, which will be sent to the reducer. The reducer iterates the list of all the delays greater than 15 minutes associated and updates the flights with unique carrier which had greater than 15 minutes. It's not the exact code. I have just written a pseudo code. So going further on the slide, next one is a Spark. Spark is more of an framework application for us to write the big data with the resilient distributed datasets, that's called RDDs, allowing transformation and action functionalities. So I have used a Spark Scala, which also has a Hadoop yarn system. So it will be usually used to find out the best time of the day or the week or the year with minimum delays. I have just written a pseudocode in Python, and it just creates a database data frame based on a table named flights, which is stored in a MySQL server. It looks the schema of this database and calculates the normal delay, which will then finally be used to determine the minimum delays with respect to the corresponding day and the time. And at last, there is a Hive technology which will be used to do the other 3 remaining objectives. That's as the Hive is more like a SQL-like language. It minimizes the code length to 4 to 5 lines, which will be attaining the same output as would be done by the Spark or MapReduce. So in order to check if the older plans are more prone to delays, so this is the query that I have used. I will just select the required attributes, that's year, flight number, arrival delay, tail number of the plane, year on which the flight was occurring, from flights database, and with left outer join with plane data on with the foreign key tail num, that's and grouped by arrival delay. And similarly, to know if the weather has any effect on the flight delays or cancellation, I just selected the required attributes, that's year on which the flight was done, and the flight number, arrival delay, whether delay cancelled or not, and cancellation code, whether it's done with if it's cancelled by a weather or cancelled by under security purpose or cancelled because of the mechanical reasons, which that's denoted by the cancellation code. And it's selected from the flights database, which is the main mega database. And to detect the cascading relational failure delays, such that one delay airport creating delay on another, which means like if a flight is taking taking departing from one airport like JFK to the another airport in Texas. Then just to find out if the delay in one airport can be relatable to the delay in another airport. So that's I just write a sample query for that, and that's for now. Thank you for your time. Thank you.